In this video, I will describe the hypothetical substance, ideal gas, and the ideal gas equation of state. Property tables provide specific information on the properties, but they are cumbersome. A more realistic way is to use some simple relations among the specific properties. An equation that relates the pressure, temperature, and specific volume of a substance is called an equation of state. There are various equations of state, some easy and others very complex. The most straightforward and most popular equation of state for substances in the gas phase is the ideal gas equation of state. Gas and vapor use similar words. However, the gas phase of a substance is defined when it is above a critical temperature. The vapor phase of a substance is defined when it is not far from a state of condensation. The absolute pressure of gases is inversely proportional to their specific volume and proportional to their temperature at low pressures. This can be shown in symbolic terms. This equation is called the ideal gas equation of state, or the ideal gas relation, and a gas that follows this relation is called an ideal gas. R is the gas constant with a unit kilojoule per kilogram Kelvin. The gas constant R is different for each gas and is determined by the following relation. R subscript U is the universal gas constant. The universal gas constant is the same for all substances, and its value is shown based on different units. And the capital M is the gas molar mass. The mass of a system is equal to the product of its molar mass and the mole number. The values of gas constant and gas molar mass for several substances are given in table A1. An ideal gas is an imaginary substance that obeys the relation PV equals RT. It has been experimentally observed that the ideal gas relation given closely approximates the PVT behavior of real gases at low densities. At low pressures and high temperatures, the density of a gas decreases, and the gas behaves as an ideal gas under these conditions. In the range of practical interest, many familiar gases such as air, nitrogen, krypton, and even heavier gases such as carbon dioxide can be treated as ideal gases with negligible error, often less than 1%. By writing the given equation twice for a fixed mass and simplifying it, the properties of an ideal gas at two different states are related to each other. Problem 1 provides pressure and temperature of oxygen gas in a storage tank. Based on this problem, The mass of oxygen in the tank is to be determined. Assumptions: at specified conditions, oxygen behaves as an ideal gas. The gas constant of oxygen is obtained in table A1, which is 0.2598 kJ per kilogram Kelvin. This analysis must change the gauge pressure to absolute pressure by adding it up with the atmospheric pressure. Therefore, the absolute pressure equals 597 kilopascals. Based on the ideal gas equation of state, the mass of the oxygen in the tank equals 19.08 kilograms. Based on problem 2, a piston cylinder device containing argon undergoes an isothermal process. The final pressure is to be determined. Before we solve the problem, we must first specify our assumptions for simplifications. In this example, we can assume that at specified conditions, argon behaves as an ideal gas. The gas constant of argon is obtained in table A1, which is 0.2081 kJ per kilogram Kelvin. Since the temperature remains constant, the ideal gas equation can be arranged as given, which when solved for final pressure becomes 275 kilopascals.